I want to know right now, if we add the following features, what is the next level escalation? What is the next level after that? 1. Add crash recovery checkpointing 2. Add gradient histogram PNG export 3. Add JSON metric manifests 4. Add continuous versus hard comparison plots 5. Add auto PDF figure formatting. Good. Now we're not talking about features anymore. We're talking about escalation layers. What you listed. Crash recovery checkpointing. Gradient histogram PNG export. JSON metric manifests. Continuous versus hard comparison plots. Auto PDF figure formatting. That package moves the system from experimental script to instrumented research platform. But that is not the ceiling. Let's map the escalation ladder clearly. Status: fully instrumented experimental engine. Level 1, what you just described. Status: fully instrumented experimental engine. You gain deterministic recovery, visual gradient geometry, structured metric artifacts, baseline versus limit case comparability, publication-ready outputs. This makes the system reproducible, diagnosable, publishable, but it is still fundamentally a controlled experiment runner. Next level escalation, level 2. Transform it into a phase transition observatory. At this stage, you stop treating runs as runs. You treat them as samples of a dynamical phase space. New layer adds keycap, automatic phase surface reconstruction. Instead of per lambda plots, compute plateau onset surface over lambda times learning rate, entropy collapse manifold, stability boundary estimation. Now you're mapping the geometry of FFZ behavior, not plotting curves, mapping topology. Keycap 2 emergent behavior classification. Add clustering overrun histories. Convergent, chaotic, oscillatory, frozen, plateau dominant. Now your engine outputs JSON, phase underscore class, plateau underscore stable. You're no longer just running sweeps. You're classifying regimes. Keycap 3 parameter sensitivity gradients. Automatically compute del plateau onset slash del lambda, del entropy drop slash del learning underscore rate. Now you're measuring stability curvature. That's no longer experimentation. That's dynamical systems analysis. Keycap 4 invariant locking. Define theory invariance. Hard FFZ must not outperform continuous beyond threshold. Entropy collapse must occur within lambda range. Plateau width must expand monotonically. If violated CI failure. Now your codebase enforces theoretical integrity. At this stage, your system becomes a theory validation engine. Next level after that, level 3. Now we escalate again. This is where it becomes serious. Keycap 1 self-optimizing sweep strategy. Instead of static parameter grids, use adaptive exploration, Bayesian optimization, curvature-guided sampling, entropy-driven refinement. The system chooses where to explore next. Now it's a hypothesis-seeking engine. Keycap 2 real-time regime detection. During training, detect entering plateau region. Adjust lambda dynamically. Log bifurcation transitions. Now you're doing controlled phase steering. Keycap 3 cross-model generalization tests. Autorun, MLP, CNN, transformer block. Check whether FFZ plateau geometry persists. Now you test universality of behavior. Keycap 4 experimental reproducibility packager. Auto-generate, Docker container. Exact dependency freeze. Manifest, DOI-ready archive. Now it becomes a publish and archive machine. Final escalation, level 4. This is the ceiling. The system becomes a dynamical field laboratory. It no longer studies FFZ only. It allows plug-in operators. You can test FFZ, hard clipping, L2, learned regularizers, novel operators, under identical instrumentation. Now it's a regularization phase transition research platform. At that point, you're not validating a method. You're mapping a mathematical landscape. Summary of escalation path. Level. What it is. Current. Instrumented experiment runner. Level 2. Phase transition observatory. Level 3. Adaptive hypothesis engine. Level 4. Generalized dynamical operator lab. The real question. You're not asking what features next. You're implicitly asking, do we want to prove FFZ works, or do we want to map the geometry of regularization itself? Because the second path is deeper, and you're already positioned for it. If you want, I can now architect level 2 cleanly, or jump straight to designing the level 3 adaptive engine. You're at the fork.